Now we want to move on to talking about fractions and rational numbers. A fraction is an expression a over b, where a is referred to as the numerator of that fraction, and b is referred to as the denominator. Any number that can be written in this form, a over b, where a and b are numbers, can also be referred to as a rational number. We do have a specific restriction that we need to apply to this type of number, though, which is that the denominator b cannot be equal to 0. The numerator can be equal to 0, so we can have a fraction like 0 over b. That fraction would be exactly equal to 0 as long as b is not equal to 0. A fraction like a divided by 0 we would refer to as undefined, or in the very specific case where we have 0 divided by 0, we would refer to that as indeterminate. But for our purposes, that distinction is not important. All we really need to keep in mind is that we can't divide by 0. So our fractions can't have a 0 in the denominator. In example 1, we're asked to pick some values given some particular constraints. In each case, we want to choose a rational number, which is another way of saying we want to choose a fraction, a number that can be expressed as a over b, that's greater than 0 but less than 1. An example of this would be 2/3. In this case, the numerator is less than the denominator, and we refer to that as a proper fraction. If the numerator is smaller than the denominator, we have a proper fraction, and our fraction is somewhere between 0 and 1. In part B, we want a fraction that's greater than 1. Now what we need is a case like 5/4, where now the numerator is greater than the denominator, and we refer to this as an improper fraction. So both of these fractions are completely valid. We just have that proper, improper distinction to reference whether the numerator or denominator is the larger value. If the denominator is larger, we have a value between 0 and 1. If the numerator is larger, then our fraction represents some value larger than 1. We can also pick a rational number that's less than 0, something like -2/3, or say -5/4, calling back on either of the answers we gave in parts A and B. But we do need to mention something about how negatives connect to or work with fractions. If we have a fraction, a over b, and let's say that's a negative fraction, we have a negative sign out in front of that fraction, we can also rewrite this as -a, or the opposite of a, over b, or we can rewrite that as a positive a over a negative b, or over the opposite of b. That means the negative associated with a fraction can apply to the fraction as a whole out in front. We can apply it to the numerator, or we can apply it to the denominator. The one thing we need to make sure we avoid, though, is applying that negative sign to both the numerator and the denominator simultaneously. We think of it as being a negative number over a positive number, or a positive number over a negative number. And then in example 2, we're asked to rewrite 4 as a rational number. So 4 is a whole number, a natural number, an integer. but we can take any integer value and turn it into a fraction simply by putting it over 1. Because 4 divided by 1 is exactly equal to 4, so we can always move back and forth between that integer notation and rational number notation if it suits our purposes in a particular problem.